Let's multiply these radicals together. So the rule is you can only multiply or divide radical expressions, if they have the same index. So you have to make sure they have the same index first. So let's look at number 1. Can I multiply number 1 together? No, can't do this. So 1 has an index of 3, 1 has an index of 2, cannot multiply. Number 2, can I multiply them together? Yes. Okay, so what you do is if you can multiply them together, you just multiply the radicand. So cube root of -8. What's the cube root of -8? -2. Number 3, can I divide?
No.
Do they have the same index?
Oh, yeah.
Yes, so I can. So I'm going to just put them as one big fraction under that radical sign. And I'm going to just divide. So 18 divided by 2 is 9. X to the 5th divided by x cubed is x squared. Okay, what's my answer? 3x with absolute value. Because the index is even, it comes out as an odd exponent. All right, try number 4. Actually, let me do this with you. Index, sorry, can I divide them? Yes. So this is the cube root of 162y to the 5th over 3y squared. 162 divided by 3 is 54. And then y cubed. Can I cube root 54 evenly? No, I cannot. And please don't use your calculator and get me decimal. We don't want decimals. We want to be able to just simplify it. All right, so cube root of 54. Okay, so basically we're looking for something that has 3 of a kind that can come out. 54 is what times what?
3 to the 4th.
No, it is not 3 to the 4th. Huh? Just give me 2 numbers that multiply together to get 54.
9 and 6.
9 times 6. Okay, we want to do factor tree. So do factor tree if you cannot figure it out. But factor tree sometimes is too slow, so hopefully you don't do that for the entire chapter. But if you cannot figure it out, of course, do factor tree. Okay, 9 is 3 times 3. 6 is 3 times 2. So what you want to do is get it all the way down to the prime numbers. Then you look at which ones have 3 of a kind. That comes out. Depends on the index. If the index is 2, you look for 2 of a kind. If the index is 3, you look for 3 of a kind. Okay, so this becomes 3 comes out. 2 stays inside. And then there's a cube root. Make sure the index stays on there. What about a y? Y cubed. It comes out as y. Does it need absolute value? No, because it's an odd index. All right, let's try it. Let's have you, number 1's kind of easy. So let's try 2 and 3. Okay, let me know when you're done with 2 and 3. Okay, first of all, check the index, make sure we can multiply, which we can. It's much better if you don't multiply the numbers together. Okay, now do factor tree. 72 is 8 times 9. 8 is 4 times 2, which 4 is 2 times 2. 9 is 3 times 3. 10 is 2 times 5. Okay, so anytime you have 2 of a kind, it comes out. So that is 2 comes out, 2 comes out, 3 comes out. Okay, so that's 2 times 2 times 3. 2 times 2 times 3. 5 stays inside. All right, x to the fourth. X to the fourth, there are 4 x's, so 2 of them come out, and that is x squared. Y to the fifth, there are 5 of them, 2 of them, 1 stays inside. Oh. Okay. Sorry, let me just finish this one. Okay, no absolute value on this. And let me give you the last one just so you can check. All right, so last section, 6.2, we did go through half of 6.2 last time, and we already talked about, how to do all these warm-up questions, but we'll practice more today. In 6.2, there is another skill that we have to learn that is called rationalizing denominator. All right, so we are on page 2. Page 2 of our notes. All right, so the rule about rationalizing denominator is you cannot have square roots or any kind of roots in the denominator. Okay, so for example, this one, 1 over square root 2, that square root 2 cannot be there. So in order to get rid of it, we need to make sure we multiply by something. All right, if you look at the square root 2, so we cannot have this in the denominator, so we need to do something about it. If you look at the square root 2, what is the index on the square root 2? 2, right? So there's an invisible 2. If there's no index, it means 2. So square root 2 has a 1, 2 inside, right? How many 2's do you need to have it come out of the square root? 2. You need 2 of the same, right? Because the index says 2 of the same. So how many more 2's do I need? 1 more. 1 more. So then I am going to multiply by 1 more. So the whole idea is I don't want this in the denominator. I want to get rid of it. To get rid of it, I am going to try to get it out of the root. Well, the root says I need 2 of the same. I only have 1, 2, so I need another 1. So I'm going to multiply. Well, you cannot multiply something unless you have the same thing on the top because you can't change this expression. So we're going to multiply top and bottom by square root 2. Okay, next, we're going to multiply across. 1 times square root 2 is square root 2. Square root 2 times square root 2 is what? 2. So that's the answer. That's how you get rid of the denominator radical. Okay? All right. I'm going to help you guys practice a little bit with rationalizing denominator or figuring out what number you're supposed to multiply. Okay? Let's do this. Can I have you guys take out your whiteboard and marker from underneath your desk? We're just going to practice. Let's come back. So, back on page 2. The standard rule is that we cannot have radicals in the denominator. If we have that in the denominator, we got to get rid of it somehow. The rule is that we cannot have radicals in the denominator. All right, so if you look at number 1, what do I need to multiply top and bottom to get rid of the denominator? What do I need to multiply top and bottom to get rid of the denominator? How many of the same do I need? How many? The index tells me how many of the same kind do I need? Everyone's like zoned out or trying to do this problem already. Okay, how many of the same do I need to come out of the radical? 3. I need 3 of the same. So how many more 5s do I need? 2 more. How many more y's do I need? 1 more. Okay, do the same top and bottom. All right, now just simplify. So I'm going to multiply the numerator together. Double check, do they have the same index? Yes. So I'm going to multiply the radicand together. 35 x, y. Over. What's in the denominator now? 5y. Yeah, because you made sure that 5 comes out. You made sure that y comes out. So it's just 5y in the denominator. Last thing you want to do is check. Do I need absolute value? No. Okay, talk to your partner. Do I need absolute value? And why? Talk to your partner. Do I need absolute value? Why? You guys can be a group over there in the back. You have a question?
It says 5 squared, so.
Oh, I'm sorry.
It's going to be 25 times 7.
Yeah, you're right. 25 times 7. What number is that? 175. Yeah. All right, so do we need absolute value? No. How many people say no? Okay, why not? It's odd index. Very good. And sorry, I made a mistake. That is a 7 times 5 squared, not 7 times 5, so that's 175. All right, let's try another one. Okay, let's try another one. So we're going to look at the one on the right. Number 2. Okay, when you have a really big radical like this where you have a fraction, just split it into 2 fractions. Cube root of 5x squared, that's the numerator. Cube root of 12y squared z. And then what you want to do is just double check. Can I simplify the radical as is? Does anything come out 3 of a kind? No. Okay, so then we're stuck. All right, we do want to find the simplest way to get things out though. So that 12 looks like it's factorable. Maybe I should work on that a little bit. Okay, so I'm going to change this to a cube root of, well, 12 is what times what? 3 times 4, and then 4 is the same as 2 times 2. So this is 2 squared 3, y squared z. Okay, now, index tells me how many of the same do I need to come out of the radical? 3. Yeah, I need 3 of a kind. So how many more 2's do I need? 1 more. How many more 3's do I need? 2. How many more y's do I need? 1 more. 1 more. And then how many more z's do I need? 2 more. All right, now let's go ahead and just multiply all that together. Cube root of. So multiply all your numbers together. 5 times 2 times 3 squared. That is 10 times 3 squared, which is 10 times 9, 90. X squared, y, z squared. What's in the denominator? 6yz? Yeah. Okay, all right. You guys are just copying it down. So let's have you talk to your partner. What's in the denominator? What came out of the radical? What's in the denominator?
12y squared.
Talk to your partner. What's in the denominator? What's in the denominator? Remember, you want 3 of a kind to come out. You did make it 3 of a kind, so what came out?
It's 6YZ, but I don't really. And,
Oh, sorry. So what came out of the radical? What came out of the radical? All right, what do you guys think? What came out of the radical?
12y squared z.
6yz. 6yz. Okay, how is it 6yz? 2 came out, 3 came out, y came out, z came out. Right? You want 3 of a kind. They do all just each have 3 of a kind. So 2 came out, 3 came out, y came out, z came out. So 2 times 3 is 6. So 6yz. Last thing. Do I need absolute value?
No.
No, why not?
It's an
Yeah, index is odd. Okay. That's a lot. Okay, let's practice. Let's see. Should we practice on whiteboard again? Yeah? Okay, let's do whiteboard again.